Welcome back. Now that you're familiar with how we can set up GPIO inputs for a high or low default state using pull up or pull down resistors, we'll move on to learning a few more skills that will be useful for the final project for level A, which you'll work on in the activities for this lesson. In this video, you'll learn other ways to use the random and time modules we worked with previously. We'll also walk through the code to trim a long number in Python, and we'll talk about how and why to use while loops in your code. Now, you've already learned how to choose a random value from a list in lesson A-13, but what if you don't want to use a separate list? You can do this by using the random.randint command. The randint portion of this command stands for random integer. You can load the parentheses after this command with a range of values. So for example, on the first line is the code you would use to choose a random number between 2 and 25. On the second line, we have the code for choosing a number between 50 and 100. And then you can use this in a program by setting a variable equal to this random value, such as in this code box. So this will cause the command random.randint to choose a random integer between 1 and 5 and then save that value in a variable called delay. You've already seen the time module used for making a program sleep for some pre-scheduled amount of time. Another part of this module can tell you the exact number of seconds that have happened since January 1st, 1970. This point in time for computer systems is called the epoch, which means a notable point in time. Currently, just over 1.5 billion seconds have elapsed since that point in time. Now, the amount of time since then isn't really important. What is useful, though, is that you can use this precise time and run the command shown here will give you the exact time from that date to this moment down to the 10 millionth of a second. So this command will output something like what you see here, a ridiculously precise number of seconds. Okay, but what makes this really useful is that it can be used to very accurately time how long something takes in your program. So for example, you could write this code to see how quickly Python can print two separate print statements. So when I ran this program, I got these values that you can see listed here as outputs. Subtracting the first value from the second will give you the amount of time that elapsed between the two print statements. So in this case, that value is 0.0003101, which we can round to 3/10,000ths of a second between the first and second print statements. So good news. That should be fast enough for anything you hope to ever program in Python, right? You don't need anything that fast. Okay, so if you wanted to time how long something took, then you could use some code like this. This program will input the time module and create a variable called time start that will equal the current time. The program will pause for 1 second, then create a variable called time total that will equal the current time minus the original start time. The last line will print the value of time total. All right, so when working with large numbers like the time module output we just looked at, it might be useful to round the digits to something shorter that can actually be easily read. Python has a built-in formatting command for just this purpose. In this code example, the numeric value 3 determines how many values will be left after the decimal. So in this case, the variable to round off will be rounded to the third decimal place and saved as the variable rounded number. Okay, so let's take a look at these three examples. If you use a 3 in the code, then we get 1.426, 3 decimal places. If you use a 1, then we get 1.4, 1 decimal place. If we use a 0, then the number is rounded off to the nearest whole number, or in this case, 1. This will make working with those huge, really precise, ridiculously precise time values much easier when you create the game program and the activities for this lesson. All right, so remember back to lesson A-17 where you learned to write the code for a loop? Now, what if you wanted to have your program keep trying to do something over and over until some condition is met? For this, you would use what's called a while loop. And here's the code to do that. So think of these as a loop that runs while we wait for something to happen. Now, the value of loop is initially set to yes. So the while loop will keep running until loop no longer equals a yes. Okay, but here's a quick warning. Don't try to run this code. Don't try to run this exact code in Thonny. Since there's no code to change the value of loop to anything but yes in this specific code, the while loop will execute forever. So this would be an endless program that you'd have to manually stop. Otherwise, it just run forever. Now, in the last video, we talked about how we can poll or ask a GPIO input pin to see if its status has changed. In the case of the game you'll make in the activities for this lesson, a pull-down resistor will have the two GPIO pins in a default state of low, and you'll need to check for that status to change to high to know the button on the circuit has been pushed. This while loop is a really convenient way to check the status of the GPIO input pin over and over until a change is detected. So in this code example, I've added a print statement. So every time the loop runs through, still looping will be printed and the if statement will be evaluated. If GPIO 20 is low or false, remember true, false, low is false, during the check, then nothing will change and the loop will continue running over and over. But if GPIO 20 is high, which is true, during one of these condition checks, then the value of the loop will be changed to no, and the while loop will no longer run. And Python will then just move on to any code in the program below the while loop. Okay, before you move on to the activities for this lesson and create that really fun two-player game, let's take a few moments and review the concepts we discussed both in the last video and in this video. Okay, now back in lesson A-16, we walked through the code to configure output pins as either high, 3.3 volts, or low, ground. But in this lesson, we learned to use high value resistors to assign input pins as a default high or low state. A pull-up resistor sets the input pin's default state to high. A pull-down resistor sets the input pin's default state to low. And remember, we should set a high or low default state and not allow input pins to float in an unpredictable state. And then we looked at the example circuit where pressing a button would shift the pin from its default low state to a high state so the button push would be registered by your program. Okay, so in this video, we talked about other uses for the random and time modules you worked with previously. Specifically, we looked at how to set a range of numbers the random module could choose from, and we looked at how to use the time module to measure how long a process takes in Python. Those time measurements turned out to be really precise, so I also walked you through the code you can use to trim down those long numbers to whatever number of decimal places makes sense for your project. And then last but not least, we talked about while loops. This is a loop that will run while you're waiting for something else to happen. It allows you to perform a process over and over until some status change occurs. And you'll use this code in the game you'll build shortly to check the status of that GPIO input so the program can immediately recognize when a push button on the circuit has been pressed. Now that you understand how to configure the input GPIO pins using a pull-up and pull-down resistors, and use the several other commands we've discussed, go ahead and move on to the activities for this lesson where you'll work on the final project for level A. Now, once you've completed the project, we recommend moving on to level B of this program, where you will learn to work with more complex electronic components, including a variety of really interesting sensors, as well as learn to write intermediate level Python code. And you can find out more information about what you'll learn in level B on our website, 42electronics.com. So have fun with the final project, and I hope to see you shortly in level B.